All right, hello and welcome back, ALEKS students. So this is another ALEKS topic that's called predicting qualitatively how entropy changes with mixing and separation. This is just another entropy topic. We've been doing a lot of entropy topics on this channel lately. I'm sure we'll be moving on soon, but in any case, this is just another pretty straightforward, basic understanding of entropy is required, and then we're going to go through these different systems and changes. To start, I really did just want to try to simplify this a little bit. Mixing causes entropy to increase. Separation causes entropy to decrease. I think if we just keep that in mind, that's sort of the key thing for going through these. And sometimes we have to sort of interpret what's going on with the change, but this is the main thing to keep in mind. Mixing, increase, separation, decrease. All right, so let's go ahead and jump into it. Over here, just in case you're unfamiliar or just want to make sure we're understanding and reading this correctly, this top one indicates that entropy, the delta S, the entropy would be decreasing. So entropy less than 0 means decreasing, staying the same. This represents increasing. The entropy of the system would be increasing. And not enough information, that would be where we have two separate changes, where one change is causing the entropy to decrease, the other change is causing the entropy to increase. In those cases, there's not going to be enough information for us to tell what the overall change is going to be. Okay, so let's go ahead and jump into it. A liter of seawater. The seawater is passed through a reverse osmosis filter. So this is semi-permeable membrane. You might see that or I've heard about that before, which allows the water to pass through, but it does not allow the ions, the salt water basically, the salt ions that are dissolved in the water, does not allow those to pass through. Which separates it into 750 milliliters of pure water and 250 milliliters of brine, which is very salty water. So here we are separating out. That means that we're going to have a decrease in entropy. Another way to think about these, you might look at this and you might say, well, this brine is very salty now, and that might confuse you a little bit. And the pure water obviously is pure water. But another way to think about this is if you do the opposite, right? If instead of this is the change, if this was sort of, the starting point and then the change was to mix these, mixing is going to increase the entropy, right? So if we're doing the opposite of that, we're separating it out, we're going to be decreasing the entropy. So hopefully that makes sense. It's a little confusing for sure, but just sort of, practice, step through it, take your time and be organized. Not too bad. Okay, next system, we've got 1 gram of potassium iodide, 2 liters of pure water. We're going to mix, right? So if we're mixing here, we're going to be increasing the entropy. Why isn't this letting me click? There it goes. If we are mixing, we're going to be increasing the entropy. That's all we're doing here. Next one, we've got pure xenon gas, 20 liters of pure carbon dioxide, both at 1 atmospheres and 27 degrees Celsius. We're going to mix the gases, keeping the pressure constant. That's going to increase the entropy. All right, we'll go ahead and do one more set. I don't think we need to go through the whole learning progression here. We've got some good examples already, but we'll go and do one more. A mixture of argon gas and helium gas. An additional 2 liters of pure helium is added to the mixture. Pressure is kept constant. We're basically mixing here, so you can sort of think about this as this pure helium gas is being mixed into this system. That's going to result in an increase in entropy. There's just more going on. Like if you just want to take a step back and just sort of do a thought experiment of imagining this system. Sometimes I like to draw little pictures. Really to this, I would just draw a little ball and then some dots inside of it. We're going to be adding more dots inside of it. That's going to increase the entropy. There's more things going on in there. More ways for those atoms to interact essentially. All right. Next one, a solution made of potassium bromide in water, adding pure water. That's going to be, again, mixing or increasing the entropy here. Very similar to this one. Just, this is in terms of solutions. This is in terms of gases. All right, the last one here, a solution of sucrose in water and a beaker of pure water, both at 37. The solution is put into a semi-permeable bag. So this is similar to that reverse osmosis, the semi-permeable membrane. That is essentially how reverse osmosis works. And 50 milliliters of pure water, so we've got the pure water from the beaker, flows through the bag into the sucrose solution. So this is pretty interesting. So in this case, from the point of view of the solution inside of the semi-permeable bag, the entropy will be increasing. And the reason for this is mixing. So what's going on in here in the semi-permeable bag, or the solution inside the semi-permeable bag, I wish I could draw this out. Apologize for that. Maybe I'll consider that for future videos. But essentially the solution inside of the bag is going to get diluted. It's going to get mixed with the pure water that's flowing into it. And this is also sort of an interesting thing to be, thinking about in terms of why that would be the case, why the water would be flowing into the bag, which is actually exactly what happened. For you biologists out there, there's some, conversations about, cell pH and cell membranes and things like that. That would be relevant here, but I don't know if pH is a thing for that. But in any case, in this for this problem, the entropy will be increasing because we're going to be mixing. Essentially, the take-home message here is that the result here is mixing. Therefore, the entropy will be increasing. All right, hopefully that makes sense. Let me know if you've got any questions in the comment section below. And thanks. Oh, let's check it. Make sure we got it right. Yay. All right. Thanks a lot.